Okay, so we're going to look at your homework assignment for today on one-dimensional motion. This is one-dimensional motion problem B. And just as a reminder, it tells us that my kids were rollerblading down the driveway this past summer. My husband decided to build them a small jump, much to my dismay, after which they lined up a whole bunch of cars and thought they were Evil Knievel. If they can accelerate down the driveway at a rate of 1.2 meters per second squared, starting from rest, it takes them 3 seconds to get to the end of the driveway where the jump is located. How fast are they going when they reach the jump? So that's the problem we're going to tackle today, and we're going to follow that process we did in class. First thing we need to do is identify our object. So what is the object of interest? Who are we interested in defining the motion for? And that's the kid. The kid that's rollerblading down the driveway. Right, then we need to determine what our initial condition is, what starts the motion that we care about, and what ends that motion that we care about. So what is our final condition? So it says that the kids started at the top of the driveway. So initial is when they start going down the driveway. All right, and where does the motion we care about end? When do we stop caring? When they hit the jump. So we're interested in the time between when they go down the driveway and when they hit the jump. Our next step was to define the world. We have to set the world. So if we have our kid, again, don't worry about how well you can draw. There's the rollerblader. We want to define that world as where is position 0. So I'm going to place position 0 right at where that kid is starting down the driveway. And somewhere down here is the jump with a bunch of cars. But we don't know what that position is. Not given to us in the problem. All right, after we define our world, we list our knowns. We're going to use that standard list. So we want to know our initial position, our final position, our initial velocity, our final velocity, our acceleration, and our time. So the initial position, where is the object that we care about locating at the beginning of the motion we care about? Well, they start out at that origin, at 0 meters. Our final position, when they hit the jump, it's not given in the problem. We don't know what it is. That remains a question mark. Our initial velocity, how fast is the object going at the beginning of the motion we care about? Well, the problem says he started from rest. So rest tells us that that initial velocity is 0 meters per second. Final velocity, not given in the problem. We don't know where that final velocity will be. The problem tells us that the kid is able to accelerate at 1.2 meters per second squared. So that's our acceleration. We want to sort of verify if the direction of that acceleration, we're always given magnitudes in our problem, does the direction make sense? If we're starting at the origin, the jump is this way to the right, we're starting at 0, we're going to get faster and faster. Moving to the right, getting faster, our acceleration is going to be positive. So we want to keep that in mind. And the time, they reach that jump in 3 seconds. So we list our knowns. Then we have to identify what we want to know. What is going to answer that question? And the problem says how fast at the jump, how fast at the end. So we want to know our final velocity. So we mark that variable that we want to know, and then we get to look at which equation is going to help us out. Final velocity is only in one of them. That's our final velocity. It's our initial velocity plus acceleration times time. So now we can look at our list and the variables that we know. Final velocity, it's a question mark. It keeps its variable. Initial velocity, 0. Acceleration is a positive 1.2. And our time is 3. So doing our quick math, our final velocity is equal to 1.2 times 3, or 3.6 meters per second. Indicating it by making a nice box around it tells us that's the variable that we were solving for. Now we need to evaluate it. Does it make sense? Magnitude, we don't always able to intuit the magnitude, so let's make sure we're at least in the right direction. It's a positive final velocity. The object should be moving to the right. They match. It's a reasonable evaluation. Good job.